Thank you and welcome. My name is Sean Donahue, and I'm the VP of Marketing and Lead Salesforce Analyst at Miro Consulting, and I'll be your host for today's event. Presenting today will be Kevin Turner, Senior Managing Analyst at Miro Consulting, and Simon Pane, Principal Consultant at Pythian. Before we begin, I'll just give you a quick, brief explanation who Miro is, and then I will let the Pythian team give theirs. So Miro is a leading global provider of software asset and subscription management services for Oracle, IBM, Adobe, and Salesforce. We specialize in license management, audit advisory, negotiation tactics, and support management. Our mission is to help our clients maximize their ROI on their software license and subscription investments, to stay in compliance, and to negotiate successful contracts and audit settlements. And with that, Simon, can you just give us a brief overview of Pythian?
Yes, Pythian is a consultancy that does support for all things related to data. We've been in business for over 25 years. And while today's talk is mostly focused on Oracle-related matters, we support all sorts of data-related technologies. So that might be your traditional relational databases, such as SQL Server, open source databases, such as MySQL and Postgres, and also document store databases, such as Cassandra or MongoDB. And we support that really wherever that runs. So that might be on premises in your data center or in any one of the clouds. And we're, of course, partners with all of the different cloud vendors. So let's start with some talk about cloud architectural options for Oracle database.
Hello, everyone. Thank you, Sean, and thank you, Simon. Thanks, everybody, for sharing your time with us today. As I am sure you are all painfully aware, the cloud is gaining in popularity. Many organizations are looking to determine what kind of a cloud scenario best fits their needs. One of the more important questions is whether you will bring your licenses to the cloud, a BYOL, bring your own license, or use the cloud licenses included with the cloud vendor, also called the license included. Oracle database licenses may be easiest to move to the Oracle cloud. However, AWS, Microsoft, Google, and IBM also allow you to bring your own Oracle licenses with you. Generally speaking, bring your own licenses is about making the most of your existing on-premise licensing and still getting the benefits from cloud-based services. You get the benefit of using all the same licenses you would already own on-premise to be licensed for BYOL, just not necessarily the same amount of license. No one-size-fits-all solution. In both bring your own licenses and cloud native licenses, you must right-size and maximize your savings. If you already own licenses, like I mentioned, bring your own license model to run your Oracle databases on either Oracle, Amazon, Azure, or Google is an option. In this model, you bring your own licenses, meaning that whatever you're running in your on-premise site, you can bring to the cloud and run them just about exactly as they were on-premise, however, in the cloud, which means that any restrictions, any limits that you've negotiated or that are part of those licenses will be the same. You would not have to migrate or upgrade your licenses unless your environment changes, it grows or shrinks. You might have to buy more or to match certain service levels as part of the licensing agreements. Some of the licensing considerations, some of the things you want to know. Bring your own licenses. You're responsible for licensing all of your software. That is still the client responsibility. Licensing is required for all of your environments. That means the current environment where you're at, if you're on premise, you're moving to the cloud, you will need to license both of those environments. So both or all of your environments need to be fully licensed because both will be up and running at the same time, at least for a certain amount of time. You also need to make sure that your support is current and up to date. There's certain clients and many people out there, many customers that are unsupported. They own the licenses and they use them without support. Any licenses that you bring to the cloud would need to be supported, under support. And of course, as I mentioned, All of the license portability to the cloud is all subject to the terms of your contracts and agreements. This includes any terms and conditions that you negotiated, any restrictions, any language that limits those licenses, or any wording in your agreements that prohibit the portability to the cloud. From a more of a technical aspect, VMware policy interpretations and rules apply. You're responsible for applying the latest patches and software updates yourself. And your disaster recovery, backup testing, things like that are all of your responsibility to not only design, but implement and test. So basically, from a high level, you're moving from on-premise to bring your own lift and shift type of a cloud experience. But it's basically all the responsibility of the licensing and many of the responsibilities for the updates and security all fall on you. And it's your responsibility to continue to monitor that, manage that, and be responsible for that in times of an audit or any kind of a review. The important thing to remember is that software is intellectual property. A software license is the right to use the product. So you don't own that software. So you have to make sure that it's being used in a manner that matches and is appropriate to the language in your contract. Also, the licensing for bring your own under support, as I mentioned, you need to be fully supported for the licensing that you bring over. If you have, you will continue for a bring your own license scenario, you continue to use your active Oracle support account and contact Oracle directly for any service request. So very much like on-premise, again, not only is the compliance and the licensing of your software, but also support is the same for bring your own. All right, Oracle OCI, Oracle Cloud Infrastructure. This has been gaining popularity over the last few years. Oracle's been really pushing this. It's fully on-premise high-performance service. OCI provides real-time elasticity for enterprise applications. Universal credits are allocated based on annual demand. Previously, this was monthly. Now it's annually or yearly. OCI offers several different flavors. They've kind of increased with their offering over the years. IaaS, which is infrastructure as a service where you can bring your own licenses and deploy Oracle and non-Oracle. Platform as a service. Customers can not only utilize infrastructure, but also Oracle provided software, database analytics, web logic, with software licenses included. Platform as a service with bring your own licenses, where much the same, but bringing your own licenses over, as we just discussed, and also cloud a customer. Cloud a customers more new. It's not a new thing, but it's more recent with Oracle. Customers utilize Oracle Cloud solutions on hardware, typically Exadata, residing at their own data center. So that's very important for people who are security conscious. There is something that Oracle has started to came out with a little while ago, OCI Support Rewards Program. This is very interesting. For every dollar consumed on an OCI PASS or IaaS service, customers can earn up to 25 cents or 33 cents for ULA client towards credit towards an on-premise support for their Oracle technology license. So this is very good. It's a way for Oracle to get more people into their OCI and get their feedback. Oracle also offers some other enticing incentives, as they all do. Oracle, IBM, AWS, and Google all offer a free tier, which also provides people with some credits and some things that they can use for free or trial in order to get your feedback.
Thanks, Kevin. Yeah, and one of the things we really do want to stress with our people on the call here is that you really should take these types of things into account. The needing for how many licenses you have, the extra support things, any discounts you're going to receive. And a lot of times we find clients, they don't actually think about these things right away, and it's good to do them at the beginning of your process. But other than that, Simon, could you take us on?
Sure. So thanks for that. And I'd like to emphasize a point that Kevin made a few minutes ago, which is that transition period. A lot of times people underestimate that license requirement and don't consider that there might be a transition period of maybe weeks, maybe many months. In some cases, it might be even a year or more, where you're running your Oracle database workloads potentially both on premises in the source environment and in the cloud concurrently. So as Kevin and Sean mentioned there, OCI is a very important part of Oracle's cloud strategy, but it's not the only option. So I like to categorize Oracle database in the cloud into 3 different swim lanes. On the left-hand side, we can see, of course, there's Oracle Cloud Infrastructure, or OCI. And by the way, I don't think that's the greatest name for a cloud. I think the greatest name for a cloud is Azure, which is the blue kind of paperclip logo they've recently introduced in the middle of the screen there. OCI, anyway, is their 2nd generation cloud. Their 1st generation cloud really wasn't that great, but they learned from their mistakes. They hired a bunch of engineers from AWS, and they built a 2nd generation cloud, which they named OCI. Originally, OCI was called the bare metal cloud service. So it's really based on a model of, or a mantra of, not over provisioning, especially on the network, and security first. So it offers some unique capabilities. And it's really what I would put in the 1st swim lane. In the 2nd swim lane, in the middle of the screen, we can see the other supported clouds. Now, I'll let my Miro friends on this call talk about the licensing implications of that. But from a support and licensing perspective, generally, Oracle treats Azure and AWS as their official 2nd-class citizens. Now, it's really interesting. I've been working with Oracle since the mid-90s, and I remember that Microsoft originally in SQL Server was Oracle's nemesis or their enemy. And now Larry is really friendly with Oracle. And for the last 4+ years, with Microsoft, has been treating them more of a friend as a foe. Clearly, Oracle sees AWS as their competitor. And the 3rd swim lane is really everybody else. And those are ones where there's maybe a little bit more licensing friction or technical support challenges. Now, what's not shown in there, but one cloud service provider that's really gaining a lot of traction and which Pythian does a lot of business with is Google. And that is Google Cloud Platform, or GCP. So unfortunately, GCP falls under that everything else category. However, that doesn't mean that a lot of customers aren't overcoming the licensing and support challenges and still moving to OCP regardless. So since they own their own version of the cloud, of course, they have taken a position where they've made more technical options for running Oracle database in their cloud compared to anybody else. So when you go to move your database to the cloud, we really need to think about how much of a managed service do we want and how much do we want to be self-managed. So while this slide mostly talks about OCI offerings, some of it's a little bit applicable to AWS as well, and I'll explain. So on the very left-hand side, we can see we can get traditional compute services, or sometimes that's called infrastructure as a service, or IaaS. And that really is just they're provisioning the virtual machines for you, or even bare metal machines, as we see. And really, you're responsible for everything from that point onwards. So patching the OS, installing the database, monitoring the database, and so forth. So that's really the self-managed option. And for that, really, you're falling under a BYOL, or bring your own license option. Now, Oracle really wants to push you further to the right. So they ideally move you more to these database managed services. And again, their acronyms are a little strange in the Oracle documentation and nomenclature. They have what's called the database service, but it's sometimes referred in acronym form as DBCS, where the C is for cloud. And that is what I would call a semi-managed service. And what I mean by that is semi-managed meaning you're still getting virtual machines and you can still access the underlying operating systems, but some of the stuff is managed for us, namely installation of the Oracle database and initial configuration. And we also have options for push button patching, which greatly simplifies one of the big Achilles heels of Oracle, which is the patching process. So we can run that on bare metal or in virtual machines. And we have an Exadata cloud service offering too. So now we can get that extreme performance that's needed. And yes, we do see that. About a month ago, I was looking at a customer who had very, very high I/O requirements. And hence, if they were to move to the cloud, unfortunately, the left two columns here, compute or DB services, wouldn't give us the I/O we need. You also have some options for running RAC or real application cluster, although as I'll mention, they're somewhat limited. So while it automatically gives you options to install and configure the Oracle database and even do minor patches, which is different than big upgrades, DB services, I would call semi-managed for that reason. And let's not underemphasize that big upgrades point. Amazon and AWS has a very similar service called their Relational Database Service, or RDS, where you can run Oracle in a semi-managed environment there. And again, we can have push button options that allow us to do little patches like our quarterly release update patches. But if we want to do a great big jump, like from Oracle 12c to 19c, it becomes much, much more complex. However, the way of avoiding that is to move into Oracle's fully managed service. And they put this under the brand name of Autonomous Database. Again, because they're thinking it's autonomous, it runs itself just like an autonomous car would. I don't personally like the name all that much. I don't like the name OCI that much. I think Oracle is bad at branding and naming things, but their technology is actually really good. And the autonomous database will cover those bigger jumps. They will do all of the patching, all of the monitoring, all of the upgrades and everything under the hood for us. And in there, we have different flavors of autonomous database too. We have a transaction processing one where the database parameters are tuned for OLTP workloads. We have a data warehouse version where it's tuned for analytic queries. And we have two newer flavors, which is the JSON database and one that's based on their Application Express low-code development environment. So that clearly is a fully managed database service. So again, in OCI, we have this broad range of technical options where we can deploy Oracle Cloud to. The other clouds, not so much, with the exception of AWS and their RDS service, where we get back into this semi-managed environment where they're doing a lot for us, but not quite everything. And if you're running on Microsoft Azure, or you're running on one of the third-party clouds, then unfortunately, you're really in the left column where you're provisioning compute resources and you're building and deploying everything by yourself. Now, as well as providing advantages in the broadness of offerings that you can choose from, they have some other advantages as well. So they have the widest available number of Oracle database editions, even going back to 11.204. And at this point, we hope that most customers have upgraded away from 11.204, but quite regularly at Pythian, we hear about customers who are at that level or lower. And it's also where you get the first flavors of brand new versions when they come out. So 21c was available in OCI before it was available for you to download and test on premises. And the next major release is going to be 23c, and we're going to see it appear on OCI before you can download it and test it on premises yourself. As I mentioned, there's additional architectural options such as RAC or real application clusters. There's automatic data guard, which means that you just click on a button in the UI and it's going to provision data guard, which otherwise can be a complicated process with a lot of DPA steps. And as I mentioned, there's an Exadata cloud service. But also when we move to OCI, again, Oracle's giving themselves their own competitive advantage by introducing new editions of the database software. So we have the normal editions like Standard Edition, which technically is Standard Edition 2 nowadays for the more recent versions. And of course, we have Enterprise Edition, which is what most Oracle databases run. But we also have two new OCI unique editions, the High Performance Edition and the Extreme Performance Edition. And each of those include Oracle options or packs, which you can purchase separately and add on to Enterprise Edition if you're running on premises or in a different cloud. But with OCI, we can buy these new editions that have these features included. And one last competitive advantage that Oracle gives itself in its own cloud is they include the transparent data encryption for encryption at rest for all of their database editions, including Standard Edition, Whereas if you were to run Oracle in any of the other clouds, you would have to have separate licenses for that. So clearly, Oracle gives themselves a big advantage in the broadness of service offerings, as well as the licensing and the additions available. So all that being said, when we move to the cloud, we usually want to think about performance. And most people will hope that performance means a big increase. And in a lot of cases, it does. But in sometimes we see it have regressions as well. So when you move to the cloud, of course, you're looking at the three core aspects of measuring performance of your database and three measurable resources that you want to architect the cloud for, namely CPU. CPU is the most important because it probably correlates to your Oracle licenses. You probably have processor-based licenses. Not everybody, there are other licensing models which Miro can help expand on, such as the named User Plus model or the Unlimited License Agreement, or EULA, as we call it. But getting the right number of CPUs for most customers is very important to make sure that we have sufficient performance and that we're in license alignment. And then, of course, databases are very memory heavy, so memory is king. And then storage is an interesting one. It takes a very different angle that I'll explain in the cloud versus running on premises. And also, we have to consider other points. So related to storage and why it differs is we have to measure IOPS, or IOs per second, or more importantly, throughput. And why do I say throughput, which is usually the megabytes per second, is more important than IOPS? Is because IOPS is how many requests we make, and the request sizes can vary. So what's usually more important is how much volume of data is going back and forth to our IO subsystems. So again, this becomes quite different when we consider moving to the cloud. So the reason it becomes quite different is this diagram on the right, which is trying to show that in the cloud, we have these artificial governors. Whereas if we configure this equipment on premises, we really don't. So there's artificial governors for a couple of reasons. First, the cloud providers want to get more revenue from you, so you pay for what you consume. And secondly, they don't want to oversaturate systems necessarily. So really, when we look at a cloud VM and the storage, we need to consider that there's a limiter on the virtual machine that says we can only do so much IO. And then there's also a limiter on each underlying disk or virtual disk. We can think of them as a disk, but really there's all sorts of magic that the cloud service providers are doing under the scenes. So sometimes people forget about this first one, the limiter on the actual virtual machine shape, and they focus just on how many IOs disks can do. But really, we need to consider both of them. And we need to consider both of them to make sure we get the IO requirements that our databases need. We don't want to have a cloud shift and have the project fail because cloud performance regresses compared to on-premises performance. So really, what the message here is that you can't just look at what the hardware profile of the machine you have is and just simply lift and shift that to the cloud. Instead, you need to be much more broad and look at what the actual database usage is, and all of your databases, combine them together and then architect for that. So that is what's called a knapsack or bin packing problem, which is how many things of value can I fit into my knapsack the most efficiently? And really that becomes a computer science exercise or programmatic problem to solve. And really the message here, what we're trying to say, is that we want to right size our cloud architecture. We don't want to under provision because we might have performance regression, which would be bad to our business. And we don't want to over provision because that's going to lead to unnecessary costs, both in licensing potentially and definitely in cloud consumption costs. But sometimes because of these limiters, we need to buy bigger infrastructure than we need. So it really becomes an art how to right size this properly. How do we get a disk that gives us the right performance, but is sized appropriately? Because the messages that I forgot to say is that really the bigger the disk, the more IOs or more throughput that it provides. So if we have a very small amount of data, but we need a lot of throughput, we might need to buy a much bigger disk, and that's what we call cloud wastage. And the way we minimize cloud wastage is maybe how we stack and combine different databases in the cloud. Probably it's going to be very different looking than it is on premises. So when we're doing a move and we're considering performance, we need to make sure that we preserve performance data of the system prior to the cloud migration. So at Pythian, we see this quite a lot. I like to use this very informal phrase to say that if you're looking for a needle in a haystack, you need to have a needle and you need to have a haystack. And in this case, looking for a needle in a haystack is trying to solve a performance problem to try and understand how did it used to work prior to our move to the cloud. And often customers no longer have that performance data. So if you have Enterprise Edition and the Performance and Diagnostics Pack licensed, you can use Oracle's AWR. And if you don't, you can use Oracle Stats Pack, which is included in all editions. My message here to this audience is make sure to turn up your retention of that performance collection prior to your cloud move. Those counters might default to only preserving 1 week worth of data, and that might be too little. You might want to have that bumped up to as much as 180 days worth of data. And if you can't keep this performance data in the database where it normally lives, then we might need to export that into some separate performance warehouse that we're manually building. So very important. And then we need to use that data to work out how many CPUs are actually required for our database. I'm not going to rely on how many are on the server that is currently running on, because as I said, that might be over provisioned or might be under provisioned. So let's look at how many CPUs are needed. And then let's consider a generation shift in the CPU models. CPUs from 10 years ago or even 3 years ago don't perform the same as CPUs for provision today. So we do a multiplier based on some public specs on that. And then we do another multiplier for some overhead. And the last point about CPU and all this performance thing is that one nice thing about the cloud is you can often, on most of the services, dynamically change how many CPUs you're consuming. So you might want to consume more and pay for more during the daytime, and then at nighttime, scale it back. Or during the weekdays, and then on weekends, scale it back. Or if you're in, say, retail and you have busy periods, say Black Friday and Christmas, you scale up CPU resources for those high watermarks in your seasonal workload and then scale it back. And especially if you're using a license included model, that can really help you save a lot. Over to Kevin.
Thanks, Simon. Great. I put this slide in here for a couple of reasons. Number one, the reason is Google doesn't get the love that AWS and Azure does from Oracle. Oracle is very big on mentioning AWS and Azure, and they have them in their policies, and they have them in a lot of their literature, but not much on Google Bare Metal. I thought I would just throw this slide in here to mention that. It's very similar, bring your own license, as I described with AWS and with Azure. Google also has something called the Google Cloud Virtual VM Engine, GCVE. It's very interesting. It's fully managed VMware as a service managed by Google or a third party cloud provider. And one of the questions that we get a lot with this, especially recently, is how it's treated. So the one thing I would say is if VMware is used within a Google Bare Metal environment, then it should be treated the same as on-premise, as far as the licensing goes and as far as how it's segregated and licensed. If VMware is running within GCP, then it is considered to be part of the Google Cloud, and as such, the products used for that would require some extra negotiating or to get certain concessions. So there's some questions there related to Google Bare Metal and Google GCP that are very important to note, and that it's not the typical usage that you would normally say with AWS or Azure. There are some things there that you need to look into before you move through it, ask the questions, and see what you can do and what you can't do before considering that. But I wanted to bring this up that Google does have a bare metal solution, and that it's pretty good, and that you should be aware of those potential issues.
And I'll just quickly add that Miro works directly with Google in terms of assuring assuring Oracle customers that yes, they can move it to a GCP, and yes, it will be done in a way that is compliant with the licensing. So just if you have any questions on that or concerns, you can always contact us here at Miro. Just like if you have any technical concerns about that type of move, you would talk to Pythian, and they could absolutely help you. They are also a very high-level Google partner.
Yes, and I'd like to just add that we have deployed, of course, to Google's bare metal solution and also to the GCVE, including running Oracle RAC on GCVE for customers who had the license ability to do so.
Thanks, Simon. Thank you, Sean. Some common Oracle migration methods. Now, there's a lot of ways to skin a cat, a lot of ways to migrate. I chose these three because these three are common Oracle methods that are mentioned by both Oracle and AWS. Now, there are these three Oracle Recovery Manager, RMAN, with the DataGuard physical replication, or Oracle Data Pump, and Oracle Golden Gate. Now, first one, RMAN with DataGuard, those are no extra cost licensing. Those are included in your database. So they don't have all the bells and whistles potentially as some of the other methods, but they are also no extra cost and are included in your licensing. So there's some pros and cons to those. I won't list them out individually. You can see here there, though, that you may not be able to upgrade your version or edition, can't make changes, things of that nature. Oracle Data Pump is the second one. It's a very common one. The issues here, potentially issues, are that if Data Pump is probably the best tool to migrate, but if it uses the import-export compression, then it will require advanced compression license. So that could be an extra cost that you didn't know about or didn't anticipate or didn't expect. It's something to be very aware of. And then the third would be Oracle Golden Gate. And as we should all know, I know, I get a lot of questions on Golden Gate. It's a great product. It's got all the bells and whistles that you could want. But of course, with anything else, a license is required, and that license can be very costly. So those are three considerations when looking at these three methods. They're mentioned a lot, and they all have their pros, their cons, and potential.
And I will add that when it comes to the typical types of audit failures we see most often, using advanced compression without a license is up there probably in the top 10. We see it a lot. It is a small feature that a lot of people wouldn't think need a license, but it in fact does. And we generally find that the majority of people who thought they had one, in fact, did not. So double check your contracts or find someone to do so, and make sure that if you are using advanced compression, you do have a license for it.
Yeah, that's a great point, Sean. And it doesn't matter whether it's in a cloud or migration or whatever you're using it. That is a one that we find a lot when we do our research and look into our clients' files, that they're using it and not even knowing it. So that's a big thing.
And I would just like to add that to me, this becomes the technical Rubik's Cube of a problem to solve. And it becomes very interesting to us at Pythian because there's other non-functional requirements. Licensing, of course, as these guys mentioned, is a very important one, but there's sometimes things like downtime. There's sometimes the need to segregate data, remove dropped columns and things like that. So while on the left-hand side, RMAN and DataGuard seem like easy and reliable solutions, sometimes we need to move to the right-hand side of this page and Oracle Golden Gate, things like that, to be able to handle other technical requirements. And sometimes we have a hybrid of different technologies here. We use these in conjunction with each other to meet the needs. So it's really a fun technical problem to try and work out for us.
All right. One of the things we absolutely wanted to cover here was, you want to plan for your costs. And with OCI, there's really no equivalent, but AWS has a really good option for savings. They have savings plans that you can purchase and essentially figure out how, if you know how you're going to use the system, you know what you're going to have, you can purchase a savings plan and get a pretty nice discount. You can get up to, I believe it's 72%. So one of the things we do at Miro, and which we're mentioning here, is that you can actually turn something on called the cost and utilization reports. They're not turned on by default within AWS, but if you're looking to find out what you're actually using and how much of it, and are you, getting the right prices for it, that's something you would turn on and it would start building up that background data. Just like Simon was talking about, you might need to get a better picture of what you're actually doing in your usage before you make a migration plan. This would enable you to essentially understand, now that you've migrated, are you actually getting the best costs? And I really like to give examples with this, with a couple of stories that we found with our clients who tried to use savings plans. We had one client who purchased a savings plan, and then as their needs slightly shifted, because they purchased a very restrictive savings plan, they actually started using servers that were not covered by their savings plan, and they ended up paying double, not even realizing it. We had another where they had a good savings plan, and somebody somewhere got a message to renew it and declined it and didn't tell anyone. So they went quite a while paying full price without realizing they had it. And the other warning I really like to point out, we had happened with one of our clients, is sometimes our clients try to go for the best savings. They want to go with that really high number so they can, walk into the boss's office and say, hey, look how much I was willing to save us. But what they don't realize is some of it can be very, very restrictive. And the two times we saw clients run into problems with that is, one, a client got purchased they were in France, and they got purchased by a German company. And their licenses only allowed them to be used in France, but because the company was now a German entity, it couldn't use the licenses. And that happened. We were able to get them worldwide usage rights, which is, again, one of those things, check your contract for. If you don't have worldwide usage rights, plan to use them worldwide. If you change locations, you may violate it. And we had the final one. I love to give this one as an example. We had a client who they wanted to achieve that top level savings plan, and they bought one that restricted them to a single location for AWS. So AWS has multiple data center locations. And that made it so that they couldn't put their disaster and recovery stuff into that same region because it was obviously a best practice. You don't want your disaster recovery sitting right next to your main systems in case that data center for some reason goes down. So those are just the sort of examples we'd like to give. And so we encourage, if you do go to AWS, keep in mind that those exist, and that also you can turn on this AWS CUR report to get a better idea of how you're using it and how you can save some money.
Okay, so we all hear in the news about security breaches related to the cloud. So customers sometimes ask me, is the cloud not secure? And the answer is no. I think the cloud is very, very secure. It's probably much more secure than anything you're going to build on premises. The challenge, though, is how do you use those security capabilities and make it secure? So when it comes to security recommendations, I have a couple that I really like to emphasize to my customers. First of all, if you need to harden your database security, and by the way, I think there's probably opportunity to harden almost every Oracle database from a security perspective, just because Oracle database has such a massive suite of security tools and capabilities. It's probably best to do that first and then move to the cloud. But more significantly is when you're considering moving to the cloud for the first time, is we need to think about personas and who's responsible for what, and separation of duties, or SOD. And what I really believe is that we need to define who is our cloud security expert. So hopefully you have a security organization or security group within your company that is going to take that on. What I see, however, though, is a lot of times the DBA gets that added to their shoulders. Probably that's not the most ideal approach. Usually we should have separation of duty. We should have somebody who's got this new role of being the cloud security person. And of course, the database is a very important part of that, but we need to look a lot more broadly. So when we think about cloud security, first of all, as I mentioned previously, if you move to Oracle's cloud, it includes a couple of extra security options. First of all, within the database, we can start to use TDE to protect our database at rest. So our files at rest from any bad actor who might compromise the virtual machine operating system. But more significantly, in my opinion, is that we have new secure cloud security tools. And I think Oracle's security tools that they provide in OCI are some of the best, although other cloud vendors provide similar tools as well. So the main ones that Oracle provides is a tool called DataGuard. And what DataGuard does is it analyzes your Oracle databases and provides a number of things, including security recommendations. It's identifying exposures and recommendations of how you can remediate that. Now, Oracle does provide a tool called the Database Security Assessment Tool, or DBSAT, which you can run against each database one at a time on premises or wherever you might run it. That's a decentralized approach. That's a tool that you're running against each database. DataGuard allows you to build a single pane of glass where you can monitor all of your Oracle databases and see all of the security findings centralized. So we can see across the board how many places we have security vulnerabilities and where our security posture is improving. And hopefully that is the direction it's going and it's not getting worse. So Oracle's direction for security tools is to try and leverage OCI and build centralized supersets of their traditional scripts or tools natively in OCI. Now, an interesting part about DataGuard is that it's included with no additional cost for monitoring any Oracle database targets that are in Oracle Cloud. But it also has a connector. It allows you to monitor, and when I say monitor, I mean do security assessments on Oracle databases that are maybe still running on premises or even in third-party clouds such as AWS. However, there is a cost for each target that you want to do security assessments on that are outside of OCI. And another one, which is not database centric, is called Cloud Guard, which allows you to guard your entire cloud state and try to look for vulnerabilities. They have a vulnerability service, which will look for things like we have unnecessary open ports and other such things. So my message really is that when you move to the cloud, first of all, make sure we're moving something that's already been hardened. But secondly, let's not underappreciate that this is a new job role that's required. We need to have somebody who is our cloud security officer who's going to be responsible for it. And we need to have cloud security technical folks who are responsible for making sure these security tools are in place and being used properly. And if we do both of those things, then I wholly believe that the cloud is not less secure, but is more secure. When we hear about breaches in the news, it's usually because of misconfigurations and accidents, not because the cloud is fundamentally insecure.
Yeah, we always say that don't make security your DBA's 25th job responsibility. Just like you don't make licensing his 26th job responsibility. There's a lot of great DBAs out there who are really good at their main job. They're great at keeping the systems up and running it proficient, but they just don't have the training and experience. So we really recommend when it comes to those two things, don't let it become a huge nightmare or a multi-million-dollar problem. Be involved at the executive level.
And I couldn't agree with Sean more. And I think this is breaking a pattern. So we have a anti-pattern to that has evolved over the last 10 or 15 years, which is when Oracle in 10G added their own storage management layer, and they thought that storage administrators would be separate to DBAs. No, most companies gave the responsibility to the DBA. When Oracle started making hardware themselves with engineered systems like the Oracle Exadata launched in 2009. Again, they thought there would be different separation of duties and different roles, and we would have hardware administrators. But no, the DBAs become responsible for more. So this is a bit of a negative pattern. And as Sean just mentioned, this is the time not to make it the 25th responsibility of the DBA and to try and go in the right direction and actually carve out a separate role or persona within your organization that's responsible for cloud security. If you do that right, the cloud can be very secure, and you have a whole suite of new cloud security tools which you can leverage and take advantage of, most likely for very little or potentially no additional cost.
I mean, I would just add to that, on top of what you guys are talking about, a lot of companies are outsourcing a lot of this work. And it's becoming very dangerous. And that's why management has to be a big part of security and licensing. You can't trust all of the outsourcing third parties to come up with your plan for you. You have to own that, and you have to hire the right people and manage the right people.
Exactly. So thanks for that, Kevin. So moving on, let's talk about how we get started in the cloud. And a lot of customers get started with just considering disaster recovery, right? So I like to think of this as almost like a crawl, walk, run type of scenario. So a lot of customers who maybe are smaller, what we might call small, medium businesses, or now they call mid-market size customers, don't have multiple data centers. So they might have an exposure, and we all have seen in recent years things, even going back to 2003 when there was the great power outage in the northeast of the USA that affected hundreds and hundreds of customers. They may not have multiple data centers, and they may not have that offsite disaster recovery. Or they might be doing it through an old traditional way of shipping backup tapes in a truck to some vault somewhere, which is very slow to do and slow to recover from. So how we start getting our toes in the water with the cloud often is through DR. So the first thing you can do is you can back up to the cloud. And actually, Oracle provides some technical modules which you can bolt onto RMAN, which allows you to write the backups directly to the cloud if you want. So some customers will leverage that, where you're writing your backups directly into the cloud. And that's why it's outside of your physical building or your premises. And it might be outside of your geography as well. So if we have an event like in 2003 with a great power outage, or something worse happens, we have geographical protection of our backups. A lot of customers like that. Other customers will take a simpler approach of they'll back up locally, and they'll do the 1, 2, 3 staged backup of first backup locally, second of all, copy it after the fact to the cloud. Either of those are fine. There's different pros and cons to each of them. I should mention from a licensing perspective, Oracle does make advantages to backing up to their cloud again, including things like compression in transit and encryption in transit when you're using their backup module. The other thing customers will do is take it a step further and maybe say, well, rather than just have backups there for worst case scenario, let's have a warm standby. And that means a passive standby that we're not actually using, but it's there and we could move to that database in the cloud if we need to. So it kind of shortens the recovery time objective and potentially the recovery point objective as well. But again, we need to very carefully consider our licensing posture and work with people like Miro to ensure that we're adequately licensed. And a third thing people like to do before jumping fully into the cloud is consider hot standby. And by that, I mean maybe offloading some workloads like reporting and creation of backups into the hot standby that all happens in the cloud. So we might keep our primary users using a primary system on premises, but we might do reporting off of a secondary cloud standby. And that, of course, requires additional licensing considerations. Of course, your processors need to be licensed, but we might also need to expand and acquire the active data guard licensing option.
And Simon, I can say this again is one of the most common audit failure situations we see, where clients think that they technically have something that qualifies as failover and it actually qualifies as standby, and the rules are very intricate on which it is. So again, we really recommend that have somebody look at that because it is one of the most common points of failure.
Yes, and Sean, not to take us down a rabbit hole, but there's the fallacy of the 10-day license rule, where
that's the one we hear.
Might believe that they have the right to have this standby as long as they don't use it for more than 10 days a year. And I believe, correct me if I'm wrong, but that's quite a fallacy.
Yeah, that's taken from something else. That's a lot of people confuse that,
Yeah.
There's that, and there's also we don't need to license our test and dev environment one. We don't need to license our DR environment. We've heard a lot of that over the years, and it's mainly all untrue. So cloud negotiations. Well, this comes down to what Sean said before, and he said a few times during this presentation. Know what's in your contract. Know what you bought. Know how you bought it and how you can use it. We discussed earlier that a license is a right to use. Well, it's a right to use in what way? It'll explain that to you in your contract, exactly what you own, how you own it, how you can use it. Cloud, the language in your contracts sets up, the terms and conditions in your contract sets up exactly what you can use, when you can use it, where you can use it. Sean also made a great point before, worldwide usage versus a more local usage. That's huge nowadays. Everybody's moving to, even if it's hosted, it doesn't have to be a cloud, it can be a hosted environment, bare metal. If you move those licenses to another country, you have to have worldwide usage to do that, otherwise you might not be able to use those licenses in this situation. For the cloud, how can you bring your license to the cloud? Is there any language in your agreements that prevent you from porting these licenses to the cloud. The cloud language in contracts has changed a great deal in the last 5 years, and it continues to change. I've seen more and more where I review contracts that are 5 or 6 or 7 years old, and they don't mention the cloud at all, whereas some of the newer ones have very specific language in them and very specific uses. For example, here I have the two about Oracle language that's written in most of their contracts and some policy about AWS and Azure. While these two here are explained fairly well, what you get for, you count 2 vCPUs as one processor and the like. Well, what about Google? What about IBM? What about the other cloud flavors that are out there? It's not mentioned. So knowing about what's in your contract and what's not is very important when you move to the cloud. You should really look into your contracts to see if you can do it first, and then what you need to change before you do. Another big one that we've talked about a little bit about before is the ULA, the Unlimited License Agreement, or ULA. It may say you can certify your licenses from the cloud to cover your on-premise environment. It may not, because the ULA agreement language prohibit you from counting the licenses during certification. That could mean a lot to a client or a customer who is counting on certifying their ULA with the cloud or in the cloud or already in the cloud. So know where you stand prior to moving forward with any cloud implementation. There are a lot of things that are written. There are a lot of things that are left gray intentionally and based on interpretation. And there are a lot of customizations that need to happen for you to be able to use your license in the proper way.
And I'll just quickly mention proprietary hosting, which Kevin has there. It's another big audit failure reason. Most of our clients don't even know what it is. Half the people who are doing it don't know they're doing it. Essentially, if you have any sort of outside group logging in, so let's say you have an Oracle database sitting behind a website, people can log in and create user accounts and everything like that, you're doing proprietary hosting. So if you are not sure, contact us after and we will help you out with that.
Yeah, and that's a huge one too, because like you said, a lot of people, it's really a custom implementation that includes Oracle licensing. It's to support a solution, multiple non-employee users, software as a service, things of that nature. So right, Sean. A lot of people on premise don't know they have that or using that, and especially in the cloud. And prior to just a year or a year or two ago, proprietary hosting was not allowed. Now it is if it's negotiated and negotiated properly. So good catch, good point. Thank you.
Okay. All right. So to wrap up, let's talk about some other technical considerations about moving to the cloud. A big one that I run into all the time is that people who are running RAC or Oracle Real Application Clusters hear from their Oracle salesperson or from whoever that they can move RAC to the cloud if they go to OCI. And that's technically true, but maybe not so true. So in this here, I'm trying to show different Oracle clustering configurations where we might have 5 computers, or what Oracle would call nodes in a RAC configuration, A through E. And in each of the colored blocks are different clusters. So when I present this to customers and they think that they can move all of their RAC databases to OCI because they've heard that Oracle supports RAC and OCI, it's true, but out of this page, really only one RAC configuration is normally movable. And that's the one in blue in the top left, where there's 2 RAC nodes, instance 1 and 2 running on nodes A and B. So yes, OCI and some cloud configurations will support RAC, but it's maybe much more limited than what you can do on site. Of course, the black ones there are non-RAC, so those ones can move. And the other colors there, well, again, it becomes a maybe, because maybe if we need to have a much more advanced multi-node RAC cluster, like I'm showing in the colors green and red and yellow, we can do that, but we need to provision a much more expensive Oracle Exadata cloud service, which is really the largest and most powerful service that we can provision for Oracle databases in OCI. So again, the message here is to understand when you hear that people say, yes, we can run RAC in the cloud, and specifically it's supported in OCI, that might be true, but it might not match the configuration that you're currently running on premises. And then if I tie it all together, this is actually a abbreviated version of an actual customer estate, where on this diagram alone, what I'm trying to show is there's 12 actual physical servers that the customer had. There's 29 different Oracle databases represented on the screen. There's 5 different rack configurations, and there's 18 individual rack clusters. So if we're moving this to, say, Microsoft Azure, where we can't officially support rack, or even AWS, and we wanted to take advantage of their RDS service, how do we architect for the cloud? How do I take these green machines where we see we have 4 green servers and they're running a dozen or more databases in various configurations, and know how much cloud resources we need to purchase and of what shape and sizes? And this is really tying back to what I said earlier, which is where you really need experts who can dig in and work out what the actual database usage patterns are and understand what the available cloud resources are, and put those all together into what we call the knapsack problem, or the bin packing problem, and come out with various options for how we provision infrastructure in the cloud. And then, like Kevin mentioned earlier, then you get into the next problem, which is how do we move there? Finally, everything we've talked about so far has had a heavy emphasis on the database workload. And the database is very important, of course. But a big failure that I see is customers who jump too quickly into deploying resources and moving things into the cloud. I like to say that you need to stop and architect and do cloud foundations properly before you start moving databases into the cloud. If you rush and just say, oh, I just created an account in AWS or in OCI, let's just spin up some Oracle databases and see how it works, you're likely introducing technical debt, which is going to take you a long time to unwind and to remove from your environment. So when you're thinking about going to the cloud, stop and think about some of the foundational stuff first and make sure that you get that right. Things like, what regions am I going into? Because different regions might have different costs in some clouds. Different regions may have different capabilities in some clouds and things like that. There's frameworks, like in OCI, we have our tenancies, and we have multiple tenancies. Within a tenancy, we have compartments, which are logical groupings, and we have to architect our network and things like that. So on the right, you can see just a sample of an architectural diagram. I'm not trying to point out that there's anything specific in that diagram, but just trying to illustrate how complicated it can get very quickly. And we might need to make multiple diagrams, some showing the compartments and logical separation of resources, some showing the networking, and some showing the IP addresses, or what's called CIDR blocks. And really, we also need to document what our standards and things are. We've seen some big complexities where customers didn't name cloud resources properly. So we need to really understand our standards in how we document and how we provision resources. And lastly, often we provision cloud stuff programmatically so we can redo it. There's usually a first attempt, and then we work out that something wasn't done quite right and we need to do it a second time. So rather than clicking through the web UI, what we always recommend is that you deploy infrastructure as code, or IAC, or configuration as code, or CAC. And that might mean for infrastructure, we're provisioning it using Terraform, or even scripts that are based on cloud CLI commands. And if we really need to do a lot of configuration after the fact, it might be a good candidate for adopting Ansible and learning about that. So just like I said earlier, there's a lot more extra work that you need to do in the security realm to make sure you have somebody who's managing that. It's very important also to do cloud foundations and do that right. And consider things like your cloud IAM, or your identity and access management, how you set up security policies. And even if we want to, instead of creating users in cloud, federate with your existing directory services, like maybe Windows Active Directory or whatnot. So very important. And I like to close on that by saying, if you're going to go to the cloud, it's best to get that foundation or base right, and then build the rest of the resources that we've talked about on top of that. So on that, I think I'll turn it back to Sean.
So I'd like to thank Kevin and Simon and the Miro and Pythian teams who helped put this all together. And of course, I'd like to thank you of our audience for spending the time with us today. Again, if you have any other further questions and didn't ask it during this webinar, please feel free to contact us either at miroconsulting.com or at Pythian.com. So other than that, this concludes the webinar. Thank you again, everyone, and have a great day.